Okay, so 4.2 is about the special exponential function called the natural exponential function. And we are going to graph functions that have e in them. We're going to solve some practical problems, including continuously compounded interest, okay, which is something that you might remember from last year or the previous year. All right, so we're going to talk about this natural exponential function. Do you guys remember where it is on your calculator? It's with its buddy. Yep, so second natural log. And it's just the natural log because that is the inverse. So e to the x is your exponential function, and it's right here above your natural log. And the base is e. Now, do you guys remember what e is equal to? Not ln, because that's the inverse. So this would be like e to the first. And you might notice on your calculator, there is a button that just says e. That is e to the first. It's right here. See that e above there? So if you do second and then e, it will calculate that for you. So it's equal to the 2.71828, and then it keeps going. And then we're going to draw a rough sketch of the graph here. So if you go to your y equals, when you graph it, you can just do second e to the x power. I'm going to bring mine back to my standard window. And you can see it looks just like an exponential function. So we're just going to draw just a rough sketch of it so we can see where the asymptote is and what's happening. Okay, so we know it's going to get closer and closer to 0. And if you do e to the 0 power, what do you get? What's anything to the 0 power? 1. And then at 1, it's going to be like the 2.7, and then it's going to get closer and closer. Okay, and so you can see it's still approaching 0, which is what we had yesterday. So you're still going to have that horizontal asymptote at y equals 0. We'll label that on the graph. So y equals 0 is still your horizontal asymptote. Okay, this point on the graph is 0, 1, because anything to the 0 power is going to be 1. And then we just talked about how to the first power, this is your value. That would be another point on there. Your domain is still going to be all real numbers. And your range is going to be similar to what we talked about yesterday. The lowest value would be 0. The highest value for this would be infinity. Okay, so there's going to be a lot of connections to yesterday. Really, the only difference here is we're not going to have as nice of numbers as we had yesterday because we're using those decimals. So we're going to sketch the graph of the functions. F of x equals negative e to the x. Okay, and for these, when you're making them, I just want to see a table of 5 values on there. Okay, and that's what we should be using. So I'm going to show you how to insert. So we're just going to go to second. See this INF? You can just insert a negative in front of what you already graphed. You can also clear and type it again, but this is the insert feature. You can just go to second and then insert, and then I'll let you put the negative there. Okay, so we're going to graph that. So again, it is approaching that horizontal asymptote, so we want to put that in there. You can use a highlighter, you can use a marker, just something that's showing this is going to be your horizontal asymptote. And because it's horizontal, it's the y equals 0. That's what it's approaching here. And just like the exponential functions yesterday, it will not cross that. Okay, so we're going to use our table to help us plot some points. So at -2, we're at -0.1. 0.14. At -1, we're at -0.37. 0, we're at -1. 1, we're at -2.72. Here we're at -7.4 or 39. Okay, so based on those points, we should probably make our scale for the y by what? We should make it by 2's, right? If it's going to fit the -10. Okay, so will you guys go ahead and plot that and then do the domain and the range?
That's why I don't like about this book. What's wrong with the hardest example?
This
Throw
is
a negative in
this is
front.
Precalc. This one's Precalc.
Oh,
Yeah, they're ready for that.
they're ready for that.
Yeah, you guys are ready for the hard examples, aren't you?
Well, e to the x goes with this. Negative flips it, right? It's a reflection.
Yeah, and so if we're going by 2's, -2, -4, -6, -8, -10. Okay, and we really do want to get a good shape of that. Okay, so at 0, you're at -1. So that reflection, before we have the intercept at 0, 1, now that's going to flip back down. Oh, thanks. Thank you, because I went by 2's. Okay, and then at 1, you're at -2.72, so it's going to be close here. And then at 2, -7. I'm actually going to use a different color to not close. And then at -3, you are at -20. So this is going to be like really, really steep here. So you can just show that part. And then this part is getting closer and closer to 0. Okay, so that's the shape that we want to see. Right, so we want that soft curve in that. And then your domain is still all real numbers. Okay, now your range this time, remember, it always goes from the lowest value to the highest value. So what is the lowest y value? -infinity. Okay, so it goes from -infinity up to your asymptote at 0. All right, and then g of x equals -e to the power of x minus 1, and then this is a big -2. So let's put that in our graphing calc. Okay, so let's put it in our graphing calculator. Okay, so for this one, where's the graph approaching? Good, -2. So that should be your horizontal asymptote. Nothing you're going to tell me about? All right, and then when you're making your table, again, we're just looking to see where some of those good points are, okay? So you have negative e to the x minus 1 minus 2, and then when you go to your table, if they're going to negative 2 here, like having a bunch of these points isn't going to be as helpful. You're going to have negative 2, negative 2.05, negative 1 is at negative 2 point, and it really doesn't matter if what you round it to, because you're going to be estimating, and these differences are so subtle that it's not going to make a big difference in your graph. So because those points are so close together, we're probably going to want to do more points on the positive side. So let's go up to 3 here. That's really what's going to create the nice curve in your graph. Okay, and so again, let's go by 2s, and I'll try to remember this time. 2, 4, 6, 8, and 10. And then with the axis, we can still go by 1s. Okay, so at 0, I'm at negative 2.4, so that's really close. At 1, I'm at negative 3. At 2, I'm at negative 4.7, so that's almost to 5. And at 3, I'm at negative 9.4, which is about here. And then as I get closer, I'm going to get closer and closer to negative 2, so negative 2.1. And so I like to put in my horizontal asymptote so I know where it is. And I'm going to label it y equals 2, negative 2. Okay, and then once you graph this, I want you to do your domain and your range. Okay, so it's following right along that line. Okay, and then your domain, all real numbers. Your range, same as before, almost. Start with your negative infinity, and it goes up to what? Negative 2. Awesome. Okay, so those are the ones that we're going to be doing on graph paper. Okay, now we're going to get into some of the real problems, the real world problems, I mean, not real. Okay. So we have an infectious disease, and it begins to spread in a small city. Wow, this seems familiar. With a population of 8,000. After 2 days, the number of persons who have succumbed to the virus is modeled by the following function. How many infected people are there initially? So whenever you're trying to find an initial value, that's going to be at the time when t is 0. So what we're going to find is v of 0. Maybe if you're in physics, you've done problems that are similar to this. Maybe you're waiting to take physics till next year. But you guys have to take physics, don't you? You guys don't?
But you can either take physics and biology or biology
and math. All right. I think there was a class that was required to take it.
Yeah, they like just started it.
Okay. Okay. So let's plug this into our calculator and see what we get. Now, when you are dividing, you can put the bottom in parentheses. All right, so we're just gonna put this in our regular. So you could put it in y equals. Do you guys want to do that? Let's do that. Because I was gonna have you do it in the next one anyway. Okay. So if you do put this in your y equals, you would have to put it in as the equation. So 8,000 divided by. Now see how you have plus here? You have to put the 4 plus value in there. Did most of you guys put it in here? In this one, calculate it. We're gonna do it both ways. So okay, so if you have e to the power of, well, anything times 0 is just 0, right? You have to put this in parentheses. That's going to give you your initial value. So initially, there were just 5 people that were infected. Okay, so you can calculate it like this. Now here it says determine the number of people infected after 1 day, after 2 days, after 6 days. So you can either, if you have one of these calculators, this is kind of cool, that you can just go back and change it and press enter, or you can also plug it in here and do this to the power of negative 0.95. Okay, so when you put it in here, you can just use your table. Oh, I wanted to show you how you could do this without your calculator. Yeah, because what's anything to the 0? What's anything to the 0, Paul? 1. 1 times this is just the same thing. So look, it's just 8,000 divided by 1,600. Cross out, 80 divided by 16, 5. All right, so what we're going to do is we're going to use our table. So we're going to go to our table. Okay, so at 0, something is wrong here.
Yeah, mine was like that. It was gave me.
What are you guys getting for this? All right, let's go back to our Y1. Yes, that's what you should have. Okay.
13 and 33.
So 8,000 divided by, and then in parentheses, you're doing 4 plus 1596 e to the power of negative 0.95 x. Then you're closing your parentheses. Okay. I really don't know what happened. Okay, so when you're looking at this for the 1, yeah, so go back and type it in again. That's what Ashley was getting to. So I want you to find the V of 1, the V of 2, and these are about people. So we're going to round to the nearest person. Okay, so for V of 1, if you have 12.87, that's going to be 13 people. And then, yeah, did you type it in the picture? Okay. Oh, I just put it back to the speaker one. Go to student. All right, and then for 2, that would round to how many people? 33. Okay, and then for 6, you have 857 people. Okay, now the next question, oh, and when you do this, you are just use your rounding rules, okay? So the rounding rules are, if it's 5 or up, I'll come help you. Okay, if it's 5 or up, you're going to round up, and if it's 4 or below, you're going to round down. Okay, oh, I gave you a hint. I was going to ask you guys to try to find that. So I want you guys to find how many people roughly get infected. So I want you to look at some really large values on the graph. So when you're rounding to the nearest person, that's okay. If you are using your normal rounding rules for that, that's perfectly fine. Now, I told you you could look at your graph for very large values. So when you graph it, eventually, if you are going to extend this, you can either zoom out, okay, or you can adjust your window. I don't know how many times it would take you to zoom out. I've been using the table. So in your table set, you can start wherever you want. So I started a very large value, like 500. And then look what starts to happen in your table. Yeah. And then, Sophia, when you're looking at your graph, did you adjust the window yourself or did you use something to help you? Okay, so you can see it on the graph. If you, again, you can just put your X value out very high, and then you're going to have to do the same thing for your max. And eventually, you're going to see, well, that's really, I don't like that it's too much. Okay, I'm going to go back and just, and it gave you a nice graph? Good. Okay, so here you can see better how you have the curve, and then eventually it's going to level off. So these functions do mimic real life, okay, because eventually, right, there has to be some type of cap to how many people get infected, because what are things that affect that value? What happens to the infected people? Yeah, they either get cured or they don't. Right? Either way, they drop out of the statistic. Okay? So yeah, we find medicines, there are cures for people. In the beginning, if we don't have the cure, then people are going to die from that, and that's going to affect the numbers. Okay, so again, I like to look at the table, and you can do your table start at whatever you want. So I usually use 500 or 1,000. Okay, to see what happens. And when you're looking at the table, you know that you found the value when you can see a whole row of the same number there. Okay, that's how you're going to know. All right, so for example 3, we have a skydiver, very brave person. The air resistance she experiences is proportional to her velocity, and the constant of proportionality is 0.2. It can be shown that the downward velocity of the skydiver at a time t is given by the following equation, where t is measured in seconds and v of t is measured in feet per second. So what we're going to do is find the initial velocity of the skydiver. And then you can see in part B, we're going to find it after 5 seconds and 10 seconds. So if we want to use the table, we can absolutely do that. I also want you to remember these rules. If you're finding V of 0, if you plug in 0 for t, then this becomes 0. What's e to the 0 power? 1. What's 1 minus 1? 0. What's 0 times 80? 0. So it's just 0 feet per second, which makes sense because if they haven't jumped yet, they don't have the velocity. Okay, again, that's something else that your table will show. So when you plug it into your y equals, you have 80, and then in parentheses, the 1 minus, use the e to the x power, and then your power is negative 0.2 t. which we're using the X for this. All right, and then we can go to, we're going to go to the table. So again, I'm going to have my table start at 0. At 0, it is 0. For V of 5, when you are rounding this, highlight the X coordinate because it rounds this for you. Okay, and then what is our direction? What do we round to? What are your directions in your packet? Okay, so we go ahead and round that to the nearest tenth, and then do the same thing for the second. And then I want you guys to practice your round and make sure you got that down. And make sure you guys charge up your calculators because you're going to need them tomorrow. I'm not done. I want to. Yeah. Okay, so it says you round to the nearest tenth, right? So you got 50 point what? 6. And then include your unit. So this is going to be feet per second. And then V of 10. 69.2 is correct. Feet per second. Okay, and now we're going to draw a graph of the velocity function. So we're going to do this in a similar way that we did on our preview sheet. And whenever you're doing this, I want you to label your axes. Okay, so we have to make sure we go from 0 to at least 70, so we could go up to 80. Okay, and then we have 0, 5, and 10, so let's go by 5s. So we can do 5, 10, 15, 20, 25, 30. Okay, and then you already have these values in your table, and if we go by 5s, we can change that. So this axis is the time in seconds. This axis is the velocity in feet per second. And again, you can choose what you want your scale to be. I'm going to go by 10, so 10, 20, 30, 40, 50, 60, 70, 80. Okay, and then we're going to plot our points. I'm going to do this in pencil. So if I'm going by 5s here, then on my table set, I can start at 0 and then make my change in my table to 5s, and then I'm going to be able to have a point for each one. Okay, so at 0, I'm at 0. At 5, I'm about 50. At 10, I'm about 70. 15, I'm at 76. Can you guys see what value these are getting closer and closer to? Yep. At 30, I'm at 79. So once you see that start to happen, this is just going to level off here. Going to keep going. And then the last part of this question is on the other page. So it says the maximum velocity of a falling object with wind resistance is called its terminal velocity. So the maximum velocity is called the terminal velocity. From the graph in part C, you're going to find the terminal velocity of the skydiver, then explain how you found your answer. So you can also, again, go to your table. And once you go to a really, really large value in your table, you can see the value that it's approaching. Okay? So your terminal velocity is 80 feet per second. Okay, and then how did we find it? So what did I do in my table? Yeah, you look for really large x values. Okay, so we examined the y coordinate for very large x values. Okay, so we examine the y-coordinate for very large x values to find the terminal velocity. So once you look at those large x values, you're going to be able to see what it converges to. I'm sorry, my ink looked kind of funky there. I'm going to rewrite it. Okay, now the other equation you're going to have given to you on your quiz for 4.1 and 4.2 is the continuously compounded interest formula. It is often called PERT because it's PE to the RT, and that's for continuously compounded interest. So you have the amount after T years, the principal, the interest rate, and the number of years. Very similar to what we had yesterday. Okay, so you don't have to have this memorized, but you do need to know what it's used for. So this will be written like at the top of the quiz along with your other equation, and you have to know which one is for which. So it's continuously compounded interest because the interest is being compounded at every instant. Okay, so in 4.1, we saw that the interest paid increases as the number of compounding periods increases. So the more you compound it, the more money you get under the same conditions. So we're going to do some different comparisons here. So the interest paid is going to increase as the number of compounding periods N increases. Those have to be under the same conditions though. Okay, you can't invest more money or have a different rate. So example 1 says a sum of $2,000 is put into an IRA that earns 7% per year. So we know from yesterday that this is our principal value and that our rate is converted to a decimal, 0.07 or 0.07. We're going to find the amount, so the A value, after 10 years, if the interest is compounded continuously. So when it says the compounded continuously, that's going to let you know what you have to use, which equation you have to use. So continuously means you're using PERT. Okay, so your A value is what we're going to calculate. 2,000 is your principal. E is just E, so you're going to keep that. And then your rate is 0.07. And then this is multiplied by the time, which is 10. And if you want to calculate that yourself, you can, because you just move the decimal. Okay, so we're going to do 2,000 E to the power of 0.07 times 10. And then I want you to go ahead and round that to the nearest hundredth. Because any kind of money, you're going to round to the nearest hundredth. Okay, and make sure you're getting the same values that I'm getting here. Okay, so you should round it to 51 cents. Okay, now when we go to part B, it says find the amount if the interest is compounded hourly. So that lets you know we're going to use a different equation. So continuously is your per equation. If it's hourly, then you're going to have to use your equation from yesterday. A equals P, 1 plus R over N to the power of NT. Okay, so that's going to tell you what equation you have to use. Okay, so the principal is still 2,000. Your rate is still 7%, but if it's compounded hourly, how do we find, well, first, we have to find how many hours are what? In a year, because it's always by year. How many hours in a year? 520. Good thing I didn't ask you that one, because you guys would all know it, wouldn't you?
I just multiplied.
Well, so there's 24 hours in a day. There's how many days in a year? Okay, so want to do some chemistry? 24 hours over 1 day. Yep, times 360. Sorry, we don't need the big side, do we? In 1 year. So then this is what happens. You just do this. The days cancel, and this is going to be how many hours in 1 year. Yeah, so, yep, 8,760 hours. If you guys don't know that, you need to watch. Okay, so that's how many hours. No, thank you. How dare you? Well, just listen to that song. Okay, and then, so it's 8760 multiplied by 10. Okay, so let's go ahead and calculate that. And then once you do that, you can answer part C. So go ahead and do both of those. So I want you to practice putting it in your graphing calculator. Yep, and then check with your row to see if you guys got the same thing. That's fine.
I think it's the same thing.
All right, so let's make sure we all got $4,027.47. Yes. Okay, so if you made a mistake, that's okay. Let's use this to help us. So did we remember the 0 in between the decimal and the 7? Because sometimes that is something that is easy to forget. Did we multiply by the 10? I put mine in double parentheses, but some of you didn't do that and still got the same answer, so that's fine. I'll always put the fraction in parentheses because some calculators don't do that. Some do. All right, and then which account, the one in Part A or Part B, is going to give you a better return on your investment by how much? So they're very, yeah, technically Part A. This is not much. Okay, so compounding continuously, or you can say Part A. I don't care which one. Okay, will earn you how much more? 2 cents. So 2 cents more. Yeah, I know. Giving you, yes, a better return on your investment. So if you get something that's hourly, that's really good, right? Hourly's a lot. Okay, remember yesterday we did some quarterlies. Okay, so depending on what the difference is and how many times a year it's compounded, that's going to affect by how much more it is. So hourly is pretty much just as good as compounding continuously. Okay. All right, and then example 2, we are going to pick the best rate. Is it A, B, or C? Okay, and then we're just going to explain. Now, this one's a little bit different because all they give you is the interest rate and the compounding periods, and you have to decide which one is the best investment and then just explain why. So they give you the 3.5% per year. So how would we write that as a rate? Yes, 0.035. And then it's quarterly, so your end value would be 4. For 3.25%, your rate is 0.0325. And compounded monthly, so that will be 12. And then the last one is continuously. So for both of these, you're going to use, well, both of these you don't use the PERT, but you are going to use PERT for the last one. Okay, and then for that one, they just give you the rate. Well, if you are going to use either one of these formulas, what else do you need that you don't have? You don't have the principal, okay? It doesn't matter what the principal is. You can decide. So you pick an investment value in a period of time. I just used 100 because it's simple to calculate, okay? And I use 1 year because that's simple to calculate, okay? So 101 year. All right, so let's calculate and then we'll compare. Okay, so 1 year. And then can you guys set up the other two and then calculate them and then we'll check them, okay? right, so let's see what we got. And if you're using 1, you know that's just going to be 12. Okay, so let's check those, and then if we need to go back and recalculate, we need to do that. Okay, so which one is going to give you the best return on your investment based on this? Choice A. Choice A is the best return, and we're just going to say by how much. So if you used a different value, your answer by how much would be different, but that's something that you're going to have to say on your quiz, so I want you to practice that. So choice A is the best return. Okay, and you, from 30 to 55 cents, how much did you earn more? No. Okay, so you earned 25 cents more than choice B, and how much more than 103.05? And you can either write 50 cents like this, or you can write 0 point, and then the dollar sign goes in front, okay? And 50 cents, you're 25 cents more than choice B, and 50 cents more than choice C. Nothing. I'll just be very okay, and then once you have that, your 4.2, there is a space for that. And then I want you to make sure that you have your graph paper. 313. Okay, so if you guys want to like do the 4.2, you guys want to do the 4.2 like tonight and turn it in. I already have that space up, or if you want to do one tonight and then just come in and work on the other one, you can do that, okay?